All right, here's a quick look at the stuff that comes in the box. Dual voltage machine, so there's 2 power cables. Weighs about 46 pounds according to Lincoln Electric's website. And I'm going to put it on the welding cart that I recently built. First up, 30 thousandths thick 6061 aluminum. That's about 0.8 millimeters thick. I'm going to be using a really sharp electrode for this thin stuff in a number 6 stubby gas lens setup. You see, at really low amperage, you can get some arc wandering even with a sharp electrode, but when I sharpen it a little bit more and then reduce the AC balance from 70 to 67, I got a really stable arc that lit up really nicely on the edges at low amperage. Now, I don't weld all aluminum with this sharp of an electrode. We'll show a little bit of that later in this video. I'm only running about 12 or 13 CFH. And so let's run down the machine settings. AC TIG. And it's 30 thousandths thick. That's 0.8 millimeters thick, so I'm going to set it at 45 amps. 67 on the AC balance, and AC frequency I'm going to crank all the way up to 150 hertz. That's the max this machine goes to. See that lighting up on the edge there? I've got this magnified so it looks thicker, but that's a 1/16 filler wire. So you can kind of, in reference to that, you can see that the metal is a great deal thinner than the filler wire. It's 30 thousandths thick. Didn't have any trouble lighting up on the corner. Even though this machine is rated at a 25 amp start, it's only for just a few milliseconds, so you are able to light up on the edge of some fairly thin aluminum. Now you see me using a Pyrex cup here, and you're going to see different cups in this video. One reason I was experimenting with what works better for filming. Another reason is I broke the Pyrex cup midstream, so you see both in the video. Well, that one's done. That's, again, 30 thousandths thick. I used a fixture that's capable of putting argon backing gas, but I did not use any, and still got decent penetration. Argon does help on a smooth root side of the penetration on aluminum. It's just not always necessary. An awful lot of aluminum is welded without any backing gas. Here's another application where really high AC frequency can help in having that sharpened electrode. A really thin lap joint. This is only about 45 thousandths, only about 1.1 millimeter. Sometimes you need a small bead. Really a lot easier to get a small bead with a sharpened electrode. There is a rule of thumb for sheet metal welding anyway that says it takes roughly 1 amp per 1/1000th of inch of thickness. Well, for aluminum, that kind of goes out the window because frequency changes it. If you use high AC frequency, you're going to need a little bit more amperage a lot of times. And also when you have chill factors, like this is in a fixture, even though it's only a carbon steel fixture and it's not pulling a tremendous amount of heat out, it still is pulling heat out and requires more amperage. This is an example. 45 amps on 45 thousandths thick metal, and you can see it's very cold. It's just laying on top. Had to increase it to 65 and actually peaked out around 63 using a foot pedal. That was about right. So if you have chill blocks or anything like that, and I actually needed a little bit of chill, small pieces of aluminum like this get saturated with heat really quickly. All right, there's the cold part. You can see it mic'd out at 46 thousandths. No penetration there, or very little, only when I got started. And then when I increased the amperage, much better. All right, I'm going to weld something a little thicker now. So I'm going to increase the amperage to 120, leave the AC balance 67. And instead of 150 hertz on the AC frequency, I'm going all the way down to 60, bottom of the range. Instead of using a real sharp electrode like this, I'm going to taper it more bluntly like this. That way I still get a nice pop off the tip of the electrode. Tack welding on ends where the arc doesn't wander. But nice stable arc, no wandering around even when I taper off, you might get with a ball. And it changes very little. Doesn't ball up or change shape a whole lot. That was 78 thousandths, almost 80 thousandths thick, and again, no argon on the backside. All right, we'll go to steel now. We're going to weld some of these box cutter blades. These mic out at 0.23, so just a little bit more than half a millimeter. Not terribly thin, but thin enough to test a welder out. I'm going to be using the real sharp electrode again with a ferrite cup, number 12 Pyrex cup, so I can get a long stick out so you can see what I'm doing. I don't put a flat tip on my electrodes for thin stuff like that. I just sharpen them and leave them sharp. So we'll go all the way down to 23 amps for 23 thousandths thickness steel and see what happens there. I've got these laying on a block of aluminum, and I'm just going to touch off with the sharp tip of the electrode onto that aluminum there and then pull back a little bit away from the corner. And then really quickly you can see the arc ran over to the corner of the box cutter blades and nipped them off. But I'll build up a little bit of metal on the end there where that nipped it off, and then we'll go ahead and weld it and see what happens here. So what it does is it gives you a very short burst at 25 amps, and then it backs right down. So, you know, having something thicker to light off on and then bringing the arc over to, if you have something really thin to do, would be the way to do it with this particular machine. There are machines that light off at 1 amp. 5 amps is pretty common. This is just a little hotter than that. The machine also has pulse capability. We'll get into that in another video. For right now, I'm going to crank up the amperage to 200 amps DCEN for steel, and only welded a short run there because this is a 150 amp 17 style torch, so it's going to heat up if I weld very long at 200 amps. I did crank it back to 170 amps and weld for a good bit longer. And you know, most steel, no matter how thick it is, you can weld it at about 170 amps. Just use multiple passes if you need more weld size on it. All right, you might be confused with the cup that I'm using because this is what comes with this particular machine as well as most others. A standard 17 torch with a long cup, and I changed it out to a stubby gas lens kit so that I can use the short style hardware, the short cups. So I use that number 6 cup for most of the aluminum, along with that Pyrex cup, which takes a whole different collet body with an O-ring, but that's, again, I'll go over that later. But this just makes it, I just like this a lot better, personally. I just wanted to show you this. It's something I put on there to upgrade the torch, not something that comes with it. All right, what I'm going to do now is just run a bead on some 1/2-inch thick aluminum. It's got a chamfer on it there, and this would be a common repair for a machine shop where they accidentally put a chamfer on both sides here instead of just one. So this is an instance where I would crank it back down to 60 hertz, and I'd still use the AC balance at around 65 or 67. And because I don't need to pinpoint a bead, 60 hertz makes it fan out nice and wide and would probably be what I would select if this were a real repair.